Now we said that the interest associated with the debt payment was tax deductible. Well, how much of that $17,222 is interest, and how much of it's principal? How do we know that? You're writing a check of over $17,000 to the bank. How much of that is of interest, and how do you know? You can always wait for the bank to send that breakdown at the end of the year, but if you're going to be planning for this, you need to know how to do that. So that's what we're going to show now, is how to amortize the loan so that we can determine how much of the loan payment is interest. Okay, so we're going to amortize the loan to calculate the interest payment. And we're going to calculate the total payment, the principal and interest payment for each period. And we recognize that that's needed because we need to be able to know how much is interest so we can claim that as a tax deduction on our tax returns. So today we have another chart. Again, you're probably getting tired of charts, but again, the charts, while you're learning this, provides a very easy way to show sequentially how to solve these problems. In this particular case of this loan amortization schedule, for column 1, we have the interest rate. For column 2, we have the period of which we're considering. For column 3, we have the beginning principal amount, how much money we owe at the beginning of the period. Then we have the total payment, okay, which we just calculated. Then we have the interest payment, which happens to be column 1, which is the interest, times column 3, which is the outstanding principal amount. Then we have the principal payment in column 6, which is the total payment minus whatever the interest payment was in column 5. Okay, if you think about that, it makes sense. If you have a total amount and you know what the interest is, then the residual, whatever's left, goes to pay off the principal. And then, of course, the final column, 7, we basically take the beginning loan amount and subtract out column 6, which is the amount of principal that is paid off. And that gives you the residual balance. So in this particular case, at time 0 today, now, the loan balance is exactly what we borrow. In this case, it's $75,000. We're buying $75,000 right now. So how much do we owe at that instant? Okay, $75,000. No time has transpired, so there's no accrued interest. Let's go to the first period. Okay, that first year. The interest rate was given at 10%. The beginning amount in that first year is the $75,000. We start the first year of the $75,000 that we borrowed. The total payment was given. Look at your previous slide. We said this was a fully amortized loan. We calculated with our financial calculator that our total payment was going to be $17,220. Now let's go to the column 5. We said that we would multiply this 10% interest rate times outstanding balance in column 3, $75,000. What's 10% of $75,000? $7,500. Okay, now let's go to column 6. If you look at column 6, what we're doing is we're taking the total payment, which is $17,220.50, and we're subtracting out the interest, which is $7,500. And what's that difference? The difference is $9,720.50. That is the principal then that can buy down how much money we've borrowed from the bank. The interest is the price or cost of borrowing the money. This $977.20 is a way for us to retire the loan. It's what we're going to use to pay the principal down. And then we go to column 7, which is the loan balance, and we basically say we're going to take the beginning principal balance of $75,000, and then we're going to take column 6, which is the amount we're going to pay off that principal, which is $9,720. And what does that equal to? That difference is $65,279.50. So how much do we owe at the end of the year? What is our outstanding debt amount at the end of the first year? $65,279.50. Okay, now let's go to period 2, where period 2 begins at the end of period 1. So you see in the box in red, I've color-coded that so you can see that the end of period 1 is the beginning of period 2. And then you go through the exact same process where you're basically multiplying the interest rate times the outstanding balance to come up with the interest. And then you basically subtract the interest from the total payment to come up with the principal payment. And then you subtract the principal payment from the beginning balance to come up with your ending balance. Okay, so this is not hard. Tedious, absolutely. Hard, no. And then you go through the same process with period 3, and you end up then with a loan balance at the end of the third year of $42,824.90. Hopefully you also see the joy of a spreadsheet, because the formulas of your spreadsheet are already given here. So if you know anything about spreadsheets, to do an amortization schedule, given the formulas are already given for you, is very easy to do. Okay, we now have the loan amortized. Now if we look at this amortization graphically, what you see is that the payment over the 6 years is constant, because by definition we said it was a fully amortized loan, right? Which means by its definition you're going to have a constant uniform payment over the life of the loan. So you see it's flat. If you look at the interest and compare the chart on the previous slide, notice that the interest is going down each year. Why? Because the outstanding balance of your principal is going down because you're paying it down. So the interest that you're paying, okay, is also declining because you've borrowed less money. You're paying it off. And you can see that that goes down. And although it's hard to see on a 6-year loan, if you see it, there's a curvature. You pay it off quicker at the beginning. At the end, the interest payments decline faster as you pay off the loan. Okay, in terms of the principal, notice that the principal that you pay goes up. Why? It's because your total payment is constant, and if your interest payment goes down, there's more for you to pay off your principal. And that principal is paid off slowly at the beginning and then more rapidly towards the end. And if you look at the loan balance, you can see that the loan balance is also declining until it goes to 0 at the maturity of that loan. And also it's curved so that the loan balance goes down faster as you pay off the loan. Now, why we did that was to calculate the tax savings from interest. And the tax savings from interest is calculated by calculating the marginal tax rate times the interest paid. So in this particular case, we add another column, a column 8, to the chart. In this column, we put it in red. And we basically, to calculate the tax savings, or column 8, we multiply the interest payment in column 5 by the marginal tax rate. And on page 44, it's given to you that the marginal tax rate for this farmer is 20%. So basically, for time period 1, the interest payment was $7,500. We multiply that by 20%, and it comes out to be $1,500. In the third period, interest was 5458.6. We multiply that by 20%, and it comes out to $1,091. Now, if you look at these three numbers that were just simply calculated by multiplying the interest payment by the marginal tax rate, notice that we're going to then transpose those onto the category of tax savings from interest. So you see that they show up as highlighted in blue. One of the questions that you might ask, that's a positive number. I thought interest was cost. How can I be getting a positive from paying interest? How do you respond to that? It's how much less taxes you're paying, so where's the interest accounted for? We know interest is a cost. How are we showing that? Which line? It's in the loan payment. Interest is a negative. You can see that we're paying $17,221 to the bank. Part of that is interest, so interest is a negative. But because it's tax deductible, and Uncle Sam recognizes that as a cost, that reduces your taxable income, which then reduces your tax obligation, and it reduces your tax obligation in the first year of $1,500, but tax savings is reduced over time because you're paying less interest.